Okay, so for right triangle trig, so biggest thing we got to go back to is the old SOHCAHTOA. And I remember I did this last year with some people, and um, some people I had in geometry one year. I had them again in algebra two, and then finally they were like in algebra two. They're like, we did this whole SOHCAHTOA thing, and it never. I don't understand what you were talking about. And I was like, okay, well let's try this thing again, and see if we can make it make sense. Okay, and this only works for right triangles. If we're going through the part on this one, is that if you're standing in a certain corner, that's not now. It's one of the two corners we don't know because we've got the right angle here. We know that's going to be here. But if you're standing in this corner and you're trying to figure out what this angle is, that you've got to have to kind of compare everything from that particular corner. So if you're standing here, now the one thing that's always the same, your longest side is your hypotenuse. That part is always the same, no matter what. Okay, but if you're standing in this corner, that with the O and the H is the hypotenuse, the O and the A is the opposite adjacent. If you're standing in this corner, which side would be opposite from you? You got one of these two is here, right? So basically, it's the one that if you draw an arrow through that angle, it's going to point to the opposite side. So this would be your opposite side. And since you're standing in this corner, that would be your adjacent side. Okay, so there's our opposite, there's our adjacent hypotenuse. And again, if we take that exact same triangle we have, but now we're standing in this corner, the hypotenuse is still the hypotenuse. Again, that doesn't change. But since we're in this corner, again, now the side that we're touching is this side. This side becomes the adjacent. And then this side becomes the opposite. So you just have to kind of realize where you're standing is going to change your perspective on what your opposite and adjacent sides are when you go through those. Okay, and here's where the whole SOHCAHTOA thing came in, is that based on what you have, sine, again, whether that's the sine of the unit circle or the sine, if we're talking about these triangles, it's still the same sine. That's going to be the opposite over the hypotenuse. So there's your S, your O, and your H. For your cosine, that's going to be the adjacent side over the hypotenuse. So there's your C, your A, and your H. And then your tangent, which is your T, that's going to be the opposite over the adjacent. Okay, and we're going to use those relationships to find out what all the angles are, and we can find out what all the side lengths are. Just based on if we've got one piece of information on this one, we can use that one or two pieces of information we have to then find out everything else, find all the angles, find all the side lengths, find everything else that's there. Now the one other thing that y'all know that y'all have done this forever, but just make sure everybody remembers. If we're talking about a right triangle, the hypotenuse is always going to be C. And then the other two sides, and it doesn't matter which one they are on this one, those are going to be your A's and your B's. We'll talk about that. So if you have to do Pythagorean theorem, everybody remember what that one is? Yeah. A squared plus B squared equals C squared. Okay. And again, the one thing is that C has to be the hypotenuse. The A and the B don't really matter because those will change based on which corner you're standing in, is which part you're going through with that. Okay, so what we're going to do, we're going to give you all kinds of different things that will tie in with these operations, with all these things. And again, it's a lot of calculator work today. So if you're not comfortable with your calculator, probably by the end of the day, you probably will be because it's just going to be a lot of calculator work when it comes off these. Okay, so very first thing we're going to do is we're actually going to have you do something like this, where it's not going to be any calculator use. So we're going to write the trig ratios for x and y. Now, and we're only going to stick with sine, cosine, tangent for right now. We're not going to worry about the three we added in yesterday. We're not going to worry about secant, cosecant, cotangent because we'll add those in with some other stuff a little bit later. So right now we're just going to stick with the main three, just sine, cosine, and tangent for this one. Okay, so there's our right triangle. Let's make this x and y. And then let's make this 5, 12, and 13. Okay, so when they ask you to write all the trig ratios, basically here's what they're asking you to do. They're going to ask you to find sine of x, cosine of x, and tangent of x. So and again, we don't know what angle x is, but we can figure out what that would be. But right now we're just working on the ratio. So we're basically saying we're standing in this corner where angle x is, and we've got to label everything based on standing in this corner. So again, we know 13 is hypotenuse. We know that's the longest side. That doesn't change no matter where we are. But standing in this corner, if we shade this corner in, we're also touching the 5 and the 13 when we shade in. So whatever side you're touching, that's the adjacent. The side you do not touch is then the opposite. Okay, so for sine x, that's going to be the opposite over the hypotenuse. So that is the opposite over the hypotenuse. So that is 12 over 13. Okay, cosine should be adjacent over hypotenuse. That's the a and the h. So that's 5 over 13. Sorry, 5 and 13 there. And then for tangent, it should be the toe apart. It's opposite over adjacent. So that is 12 over 5. All right. And then now we've asked for all the ratios. We're going to do for x and y. So now we've got x. We have to do the same thing for y. Now we're going to do sine of y, cosine of y, and then tangent of y. All right. So again, if we're talking about angle y, now we're talking about standing in this corner. So if we're standing in this corner, again, the hypotenuse is still the same, but now this becomes the adjacent side, which means this then becomes the opposite side. Because again, we're staying in a different corner, so now your opposite and adjacent are going to change perspectives because we're in a different corner. Okay, so for sine, again, now it's opposite over hypotenuse. 5 over 13. Cosine should be adjacent over hypotenuse, so that would be 12 over 13. And then tangent would be opposite over adjacent, so that would be 5 over 12. And if you notice on your values, basically everything changed. Sine over here in x was 12 over 13. Now cosine is 12 over 13. Sine was 5 over 13. Cosine becomes 5 over 13. And then tangent was 12 over 5. When we go to the other angle, it's 5 over 12. So it's the exact same numbers, just a different order because, again, different perspectives, so it's going to change that part of it. Okay, now the one thing we didn't ask for, we're going to add this in on this one. I'm going to ask you to find x. And this is where we get to use your calculator. Okay, now don't be the genius on the test that goes, there it is, I found it, it's right there. No, that's not what we're talking about. We're actually, we want to find the value of x, this thing. Okay, so to use your calculators on this one. This is where you can take any one of the operations that you have for finding x. We're working with any one of these, and we're going to use your calculator. Now, here's the thing on this one. If the angle is missing, Basically, when you're going through this homework, here's what you want to look at. If we're finding x, which is the missing angle, you've got to use your second button. So they gave you this part that was over here. You would have to just plug it straight in. But if the angle is missing, you're gonna have to do something like. And again, it doesn't matter which one you pick. So if we pick sine of x, here's what we're gonna do. See if we can get it here. There we go. No glare. You're just gonna hit second and sine, and then you're gonna do 12 divided by 13. Now, the one thing we got to do, if you do not get 67.3, we've got to make sure that your calculator is set. And if you notice down here at the bottom, maybe hard to kind of see, but there's a DEG down here. If we're finding this thing in degrees, we need to make sure this thing is in degrees. If it's not, then you've got to change your settings so that this thing will be set in degrees. All right, so we'll do that one more time. So whether it's Casio, Texas Instrument, doesn't matter. If it's Casio, this is your shift button, but go ahead and hit your second or your shift button and sine, and then do 12 divided by 13. Should give you 60. Whoop, typed it in wrong. Try that again. 12 divided by 13. There we go, not 1. There we go. So it should be 67.38. And whether you use sine or cosine, it doesn't matter. So if we did cosine, you didn't get that? Okay, so that's where we got to check the settings on your calculator. 60, and if we round this thing off to the nearest whole number, that would be about 67 degrees. Okay, now question is, if that's 67, how much is angle Y going to be?
67. Negative 67.
Okay, how many degrees are in a triangle? Yeah, 180, right? Now, if we know that there's 180, we take out the 90 for the right angle. That means the other two angles have to be 90, correct? If we know that angle is 67, we can just subtract that 67 from 90 and know that that other angle would then be 23. So as long as it's a right triangle, the other two angles have to add up to be 90 degrees. So if you find out what this angle is, if that's 67, just subtract that from 90 to find your other angle there, which would be 23.
Wait, why would we subtract 90?
Okay, so there's first opportunity we're looking at. All right, second thing is, let's give you a little different look to it here. Let's go with X. Let's go with 33 degrees, and that's going to be 14.
Just examples?
Example 2, yes. Okay, so just throwing you all kinds of different options of what they're going to have you do for these parts of it to get there. So here's one where this time we're not going to write the ratios. We're just going to find out what side X would be in this case. Okay, and the whole thing with the SOHCAHTOA, if you didn't quite catch this in geometry last year, then this is where we're going to try to go back to this one, is that you have to label everything so you know which operation you're going to use. Because if they give you missing pieces of information like this one, then you have to figure out, okay, there's only one correct operation that we can use if we're going to use this information that's given to us here. So basically what we're going to do is we're going to label everything based on us standing in this corner where this angle is 33. The one thing we know is this would be the hypotenuse. They did not give us a length for this side, which would be the adjacent. So the adjacent's out because we don't have anything there. The one side we're trying to find is over here on X. That's the opposite. So the two things, the one thing we're given is the hypotenuse. We're trying to find the opposite. So if we need the O and the H to work out, that means we're going to have to do sine, because if we're given the O and the H, we have to use sine for that thing. So that's going to be the sine of 33, and that's going to equal X over 14. Okay, now, we probably should have done this problem first, but I want to go back through the ratios here. If they give you the angle and you punch that one in, you do not have to use the second button. You can just take that number, plug it straight in to be sine of 33. And whatever that no second button needed on that case, that would be 0.5446 for this thing if we go through. Now, define your values. If you do or don't remember this part of it, here's kind of the good thing, is that basically you set these up like it's going to be cross products. So if we find this answer, x is going to equal 14 times the sine 33. So if we know that the sine of 33 is this, we can just take that answer and then multiply it by 14. So x should be about 7.6 if we round that off to one decimal place there. So again, we're going to do that as 14 times sine of 33. Okay, everybody okay with that one? Everybody all right with what we did there? And again, you've got to figure out which operation you actually, based on the information they give to you, there should only be one operation that you can use with that angle that they gave us here at 33. All right, let's throw another one at you here. Okay, for this triangle, we've got x. We've got to find the missing angle. We've got 20 and 9. Okay, and again, based on the information they give you, in this case, we're only working with angle x. We're not working with the other one. We've got to label everything based on angle x perspective. So if we're standing in this corner, again, we know that this is the hypotenuse. That part's always the easy thing because it's opposite the right angle. Standing in this corner, we're touching this side to draw angle x. The other side that we're touching means this would have to be the adjacent. So if we have the adjacent and the hypotenuse, we have to use cosine. So the cosine of x would equal 9 over 20. All right, and again, angle's missing, so you got to use your second or your shift button, depending on which calculator you're working with there. So we're going to go second, and then cosine, and then 9 divided by 20. Okay, again, if we round that to the nearest whole number, that should be about 63. And that's one where Math Excel, you'll just have to look and see whether they want whole number or if they want one decimal place, that would be 63 point. The 5 will move it up to be 63.3. So it just depends on what they're asking you to do, how they want you to round this thing off. All right, example 4. No angle this time. So we have no angles, which means we cannot do anything. We don't know whether we're doing sine or cosine or tangent here because we don't have any angles. So we're just trying to find the missing side. So if we're working with all three sides, just Pythagorean theorem, right? So just a squared plus b squared equals c squared. Again, a and b don't really matter. You can put those in whatever order you want. That's 5 squared plus 10 squared equals. The main thing is that your y is your hypotenuse, so that's got to go where the c is. Okay, so 25 plus 100 is 125. And hopefully this is still fresh in everybody's brain. If we've got to get down from y squared down to y, what must we do? There we go. Got a square root. Okay. And they may ask, possibly, they might ask for this in the simplest radical form. which means you might have to use your radical skill. So if we're going to do that with the 125, you got to break down the 125. We'll do that over on the side over here. If we break down 125, if we go ladder method, that would be 5. We can divide into it. That'd go 25 times. 25, you can make that 5 times 5. So 125 is really 5 times 5 times 5.
So it's 5 out 5.
Yep. So get our exit buddies. Those 5s get out. That one doesn't. So it's 5 square root of 5. Okay, now if they ask for decimal number, you don't have to worry about doing this and breaking it down and figuring everything. If you get to here and they ask for decimal number, you just punch in square root of 125 and you got it. No big deal there. You get like 11.1, I believe, or something like that. Okay, so if they ask for decimal number, just punch it straight in. If they ask for it in simplest radical form, you got to go back and break it down to get it there. Okay, and then last thing we've got here is our special right triangles, which kind of, and again, this is where we tie it all back in with the trig, with the unit circle part, is with, we kind of briefly talked about it a little bit a couple of days ago. Here's where we're going to talk about it a little bit more, make sure everybody's okay here. Okay, so there's our 2 special right triangles. Okay, and we're going to actually do this, proving it using the unit circle that we did to get there. That with the unit circle, we said that this one has to be 1. That if we're going back and, if this was back in quadrant 3 over here, this was our vertex back here. 30, 60, 90 triangle back here if we drew this one. The one thing we knew was that the hypotenuse in this case would be 1. Okay, so we're actually going to use what we know about SOHCAHTOA to go back and prove that the unit circle is actually, the numbers are correct, that I'm not just telling you something that's not true. Okay, so if we do that one, let's say we're going to use the 30-degree angle that's here. We know that's the hypotenuse, right? So let's say we want to figure out what this side is over here. So if we're doing that one, if we're using this side, we know this would be the adjacent and this would be the opposite. So if we do that one, if we're trying to find out what this side is, we know that this side is 1. Then that's going to be the opposite in the hypotenuse. So that means we need to use which operation? We got O and H. SOHCAHTOA. So, yeah, you got the so part. SOHCAHTOA. Yeah, so in that case, we got the O and the H, so we got to use sine. So if we do sine of 30, that would equal x over 1. And again, if it's over 1, we don't really have to worry about it. We can just punch in sine of 30 on our calculator, and that will tell us what we got there. If we do sine of 30, that is, in that case, 0.5. But again, if we put that in terms of what we know as a fraction, that would be a half. Okay, and then if we want to figure out what the adjacent side is, let's just call that y here. Then instead of using sine, we could do A and H, we could do cosine, right? So we could do cosine 30 over 1? Yes.
My calculator's not letting me do sine of 30.
So cosine 30, if we punch that in, Tells you it's square root of 3 over 2. So that's the two numbers we're pulling out of the unit circle with the trig part, that it's all those things together. So that's, and again, that's one of those things, if you go back and actually use one for the radius and you actually do sine, cosine, tangent, you can figure out that this side would be 1/2 and this side would be square root of 3 over 2. Okay, now here's what that means. If we're going through all the 30, 60, 90 stuff, is that if they give you the short side and you need to get to the long side, to go from short to long, you need to multiply by 2. Because again, if we go from 1/2 to 1 up here, we're just going to double that to get the distance we're looking for. If you need to go from the short side to the medium side, because we got short, medium, and long on the three sides for that part of it, you've got to multiply by square root of 3 over 2. Okay, and somebody's probably thinking, what if I don't have the short side? What if I have the medium side? Well, then you're going to go backwards. Instead of multiplying by square root of 3 over 2, you're going to have to divide by square root of 3 over 2. So if you're going from short to long, you'd multiply. If you go reverse, if you go long back to short, then you got to divide as you're going through those numbers. So short to long, it's times 2. If you go reverse, you got to divide by 2. Okay, so here's a problem they may throw at you. And we'll just do one example off this, because I think if we get one, it should make sense. Okay, so there's our 30, 60, 90 triangle. Let's say that you've got this side is 8, and you've got to find x and y. Okay, so we got to label these short, medium, and long. Basically, is always the thought process I have on this one. So if you go opposite the 30-degree angle, that's going to be your short side. If you draw through your 60-degree angle and draw an arrow through it, it's going to point to the medium side. If you draw through the right triangle or the right angle that's here, that of course is your hypotenuse, which obviously is our longest side. So this one, we got to go backwards. We got to go from the hypotenuse back to the short side. So for that one, we need to divide by 2. So in that case, x would just be 4. Okay, and then now that we've got the short side, to get the other side, the medium side here, we can just take the short side and then multiply it by square root of 3 over 2. So that becomes 4 square root of 3 over 2. But we can take 4 and divide it by 2, right? So we can just cancel that and make that 2 square root of 3. Oh, wait. I'm sorry. When you multiply, my bad. Hold on. I'm getting the mixed up here. You just multiply by square root of 3. Sorry, my bad. When you go from short to medium, you just multiply by square root of 3, not square root of 3 over 2. My bad. Hold on. It's just, I was thinking about the square root of 3 over 2 and was doing that. I was looking at the answer and I was like, wait a minute, that's not the right answer. So when you go from short to medium, you multiply by square root of 3. When you go from short to long, you multiply by 2. There's no dividing by 2 because that kind of ties in with it. My bad. I was just about to do something totally wrong there. Okay, and then last one back here, 45, 45, 90. And again, if you want to go back and we'll take my word on it, we'll go from that one. But if this radius was 1, what was our 2 lengths anytime we did a 45-degree angle? Yeah, square root of 2 over 2, right? Basically, it's an isosceles right triangle is what we're looking at. Okay, and for the 45, 45, 90 triangle, it's either one of two things. Either you're multiplying by square root of 2 or you're dividing by square root of 2. And for the 45, 45, 90s, those they call those legs. So whatever they mark here and here, those are called the legs. So if you're given either one of the two the legs, you multiply by square root of 2 if given either leg to find the hypotenuse. Okay. And if they give you the hypotenuse, then you divide by square root of 2. Which means if you're dividing it by square root of 2, that means you're probably going to have to do a little bit of, you might have to do a little bit of rationalizing like we were doing yesterday with some things. Okay, so I'll give you one example of that and we'll wrap this thing up here. So let's say that this is our 45, oh, I made a little cricket there. 45, 45, 90 triangle. And we'll do two variations on this one just so we can see. Let's say they tell you that this thing is 8 inches and they ask you to find X and Y. Okay, so if it give you, you got one of the legs here. To find out what X is, of course, X would be really easy, right? X would just equal 8 because they're going to be the same size because it's an isosceles right triangle. And to find the hypotenuse, really easy. You just take 8 and you multiply it by square root of 2. Okay. And you can leave it that way. They may ask you for, again, to change that to a decimal number, but if they give you one of the side lengths of one of the legs to find the hypotenuse, you just take that side length, multiply by square root of 2. If they had given us the hypotenuse, then we would take that number, we would divide it by square root of 2. So let's just real quick for this one, let's pretend for a minute. Let's say that was 10. They ask us to find X. Okay, again, as long as we know it's a 45, 45 triangle, we can take the shortcut. We're going to take 10 and divide it by square root of 2. Okay, and if you remember rationalizing from yesterday, we said what we're going to do, the shortcut is we're going to take the square root of 2, move it from the denominator to the numerator. On the bottom, we're going to take the square root away and just leave the 2. But 10 divided by 2 is 5, so that answer would be 5 square root of 2.